Hi, this is Mrs. LaBarbera. This is AP Physics Mechanics C. Today we're going to talk about an example for an object falling through air. Here it is. A ball of mass m and a cross-sectional area A is released from rest near the surface of Earth. The ball experiences a resistive force due to the air that is proportional to the ball's velocity. Fr equals negative BAV. This is negative means opposite of velocity. Where B is a positive constant, determine all algebraic answers in terms of MBA and fundamental constant. First, draw a free body diagram for the ball for the following situations. Given each vector description, label, and draw them approximately to scale. A short time after the ball is released. In this case, the ball is still accelerating downward, even though acceleration is decreasing, but velocity is increasing. Since acceleration is downward, so the force downward should be bigger than the force upward. You have two forces, mg and Fr, resistive force. Mg is bigger. Once the ball has reached terminal velocity, this is the case when the net force on the ball is 0, when the two forces balance. So they should have the same length, about Fr and mg. Part B, calculate terminal velocity. Again, terminal velocity happens when Fr equals mg, and that's the equation you should use. When F net equals 0, so Fr, BA at that time, V is V terminal. That should be equals to mg, so you can solve for Vt equals mg divided by BA. That is a terminal velocity. That's the maximum velocity this ball can reach. Part C, starting from Newton's laws, derive an expression for the time required for the ball to reach a third of its terminal velocity. So we start from Newton's laws, F equals ma. From here in the free body diagram, we know there are two forces, mg and a resistive force, which is BAV, and that equals mdv over dt. To find the value of v, we have to do the integral. Remember, anything has v, like plus or minus v, this is the whole term. We have to treat this as a whole term and combine this term with dv. We can move m and dt to the other side. So after you move it around, this is what you have, and you have to integrate it. So you start from 0 to any time t. Your v is also from 0 to any speed v. So we know like 1 over x dx, that is ln x. But these two terms, mg minus bav and here v, they look different. We have to make them the same in order to integrate. So again, one trick to do it is to use u sub. Let u equals mg minus bv. Now this term becomes 1 over u, but dv should be in terms of du. So to do that, we have to derive u relative to v on both sides. Du over dv, mg is 0 because it's constant. The next part is just negative ba. From here, we can figure out dv is just negative 1 over ba times du. Now we substitute u and dv into this equation. On the left-hand side, this you can factor in 1 over m out. The integrate of 0 to t dt is just t. Here, 1 over mg minus bav becomes 1 over u. dv is negative 1 over ba times du. Negative 1 over ba is constant. You can factor it out. And plus, because BA is a constant, we can multiply this on both sides, kind of get rid of it. So on the left-hand side, we have negative BA over MT. On the right-hand side, 1 over x dx, that equals ln x. And in this case, 1 over u du equals ln u. What is u? U equals mg minus bav. And what's the value of v? You start from 0 to v. Now, left side stays the same. Right side, you have to subtract the first term when v equals to v, minus the second term when v equals to 0. When v equals to 0, ln mg minus bav becomes ln mg. When you subtract the log functions, you can divide this. So on the right hand side, you have ln mg minus bav divided by mg. And on the left hand side, in order to solve for v, you have to raise e to the power of this. E to the ln of this is just that term. And I simplify this term. Mg divided by mg is just 1 minus ba divided by mg times v. From here, we can solve for v. Okay, to solve for v, again, you can add this term on both sides and subtract this term on both sides, then divide the coefficient in front of v. So this is what you have. Actually, mg minus ba, that is your vt. That's your terminal velocity. This is not it. This is just v as a function of time. We need to find the time for a third of the one, how much time when v equals a third of terminal velocity. So when v equals a third of terminal velocity, we have to substitute v in here. That's mg over ba times 1/3, which is the same. From here, we can solve for t. As you can see, mg ba over ba, mg over ba cancels. So you'll have e to the power of negative ba over m times t equals 223. How do you solve t? Now you have to do the natural log on both sides. When you do the natural log, on the left hand, you'll have negative ba over mt. On the right hand, you have ln 2 over 3. We know ln 2 over 3 has to be negative. That's why t has to be positive. So last step is to solve for t. You simply multiply negative m over ba on both sides. So that's what you have. Lastly, sketch the following two graphs of Ball's motion when the ball is released at time t equals 0 until it approaches terminal velocity. How about acceleration? Let's take a look at acceleration equation. mg, that's a net force, equals to ma. So we know in the beginning v equals to 0. In that case, a is just g. So a, you start with g. When v becomes terminal velocity, a becomes 0. When v equals mg over ba on the left becomes 0, that basically says a becomes 0. So it looks like this. It looks like this because acceleration is decreasing. So the slope actually is decreasing. Also, the rate of acceleration is decreasing, I should say. Next one, let's take take a look at velocity. Here is the equation for velocity. So when t equals to 0, velocity actually equals to 0. You dropped from rest. Then when after a long while, v becomes terminal velocity. So v has maximum value, which is terminal velocity. And the graph looks like this. It curves up because the slope of this graph represents acceleration. We know acceleration is decreasing. So that's why the shape looks like this. Okay, that's it. Thanks for watching. See you next time.